Welcome to myprojectbazaar.com. The project title is Image Denoising using Dual Tree Statistical Model for Complex Wavelet Transform Coefficient Magnitudes. The project abstract is the Discrete Wavelet Transform, that is DWT domain. It has since been optimized through the exploitation of transactionally invariant wavelet decomposition such as a Dual Tree Complex Wavelet Transform, that is DT-CWT, alongside bivariate analysis technique that conditions the shrinkage on spatially related coefficients across neighboring scales. These more recent techniques have denoised the real and imaginary components of the DT-CWT coefficient separately. Pre-processing really and imaginary components separately has been found to lead to an increase in the phase noise of transform, which in turns affect denoising performance. Project flow diagram is to remove the noise from one image by using an DT-CWT. It means this dual tree composition of wavelet transform. Initially we have to collect the dataset. In the datasets we choose one image as the input. That image going to process our DT-CWT. Next we have to apply the pre-processing steps. In the pre-processing steps, first step we have to resize our input image and separate the channel. It means RGB, R means red, G means green and B means blue, to obtain the original image. Next step, to add the external noise. In our process we using two types of noise. First one is salt and pepper noise and second one is Gaussian noise. Next we have to remove the noise by using on DT-CWT. It means dual tree decompositions of wavelet transform to remove the noise from one image. Finally we estimate the obtained image for MSC and PSNR value to measure. Our project source code file was run from the command window. In current folder shows some files. So our source code file was main.m. In our datasets there are some images. There are 120 images are collected from our dataset. So we have to run the main.m. So we have to choose 120. Among the 120 images we have to choose any one of the image. So the process will be going on. So enter the type of the noise. So which noise we have to add now. So first for Poisson noise, so we have to give the number 1 as added Poisson noise and select the wavelet. So in that wavelet we are using the coefficient. So and put enter and in 1. So we are going to apply some threshold. So we are going to apply the soft threshold algorithm. So we have to enter the 1. So enter the level of decomposition of our input image. For example I will give 1. So finally we have get denoised image. So in the denoised image we have achieved the SNR and MSC value. So we have to discuss the figures. So it is the first image as a input image. So next we have to get the resized image. After getting our input image we have to resize those image. So after resizing our image we have to separate the channel. Here I am using the 4 type of channels we have to separate. So after that separate the channel, we are going to separate the color wise. So it is red channel for 4 types to separate, and green channel for separate 4 types, and blue channel for 4 types. So we have to classify the channels. After channel separation we have to add the Poisson noise. So it is the Poisson noise. So those noise to remove the our process. So we are going to apply the denoising process for DT-CWT. It means this dual tree composition of wavelet transform. So after adding the noise, we have to remove those noise. So it is step by step to remove the noise. So in that first step we have to remove some type of noise, then next step to remove some type of noise, then finally we have to remove some noise. In that noise we are going to concatenate. Finally we have to apply the CT DWT. So finally we are getting the denoised image. So this image going to our output of the result. So according to that process we are going to run another one image. So it is also based on like that process. So enter the noise, enter the wavelet, and enter the thresholding, and we are going to give the T composition level as 2. So our finally we are getting the our denoised image. The project demo was completed. Thanks for watching this video.